Hello, this is Paweł from DevOps Codes Academy. Welcome to the next episode. Last time we were learning about application load balancer, and today we're supposed to go with the same, but do it with Terraform code. However, before we're gonna jump into the Terraform code, I would like to introduce you today into the VPC. We need to learn a little bit about basics, about the difference between the public and private subnet. So we will be able to create a VPC with Terraform code, and then we will deploy it into that VPC, our load balancer, and we will be prepared to continue our journey with DevOps and AWS when behind the load balancer, we're gonna deploy our backend in private subnets. I would like to invite you to our Facebook group, DevOps Codes Academy. You can find the link in the description. And right now, let's jump to the console. Okay, guys, we are in AWS Web Console. We're gonna go into service VPC. We have in each region one default VPC created by AWS. Usually they start with the CIDR 172, but we will not focus on it today. We would like to create our own VPC. And let me show you a simple diagram that I found on internet. Doesn't matter about the region right here, but this is what we're gonna create, a simple, the most simplest, I would say, version of our VPC. We will have 4 subnets, 2 subnets that we will call public subnets and 2 private subnets. All 4 of them will be using a routing table, and they will have their own route tables. The difference between public subnet and private subnets it is in routing, and I will show you when we will go to the creation of VPC. You can see that we have 2 more resources here. One is an internet gateway. This gateway, it is provided for us for free. It allows both-way communication with internet. It means that our virtual servers or any other resources can communicate with public internet. Let's say we can download something from the internet, but also when we have a public IP, anybody from the internet can connect to our instance. However, in private subnets, these subnets are not using internet gateway in the routing table. They will use NAT gateway. NAT gateway is a service in AWS. It's a serverless one that allows us to provide one-way communication from private subnets. And I mean one-way, it means that we can download, let's say, any patches, anything into our server. So we can send the request and we will get the response back, right? But the traffic is initiated from the private subnets, but nobody will be able to connect directly to our private subnets. We can have a bastion host, like here. This would be an EC2 instance with public IP. And if we log in, let's say use SSH to the Linux machine to this bastion host, then we can connect from this bastion host to other private resources using the private IPs of the VPC. I hope that this is quite clear, not complicated. And we will go to the console and try create a VPC for ourselves. AWS make it quite easy for us right now. And let's see, because I haven't done it for a long time from the web console, but we will learn together. I mean, we will discover how is it graphical done here. Auto-generate project. Let's say DevOps Academy. This is just a tag that will be generated, so it doesn't have to be unique. You can put whatever you want here. Then we have to define the IPv4 SID block, and you can see if we are using 10.0.0.0/16, we will have 65,000, more than 65,000 private IPs available. We can make it smaller, and as you see, when we increase the number, we are decreasing the number of IPs. Let's make it /20. We will not use IPv6 right now. Tenancy will be default, means that it's on shared servers in data centers. And we will use number of availability zones. We will use 2, the same like on the diagram, as you can see. Availability zone 1A and availability zone 1B, which is not written here. So we will use AP Southeast 1A and AP Southeast 1B. Number of public subnets 2. And as I told you, they will be publicly accessible over the internet, and we want to have 2 private subnets. And we can customize the SID blocks. But I choose /20 on purpose. So we can have a 24, or we can have 21, we can have 22. If we go like that, 22. They cannot overlap. So we will have probably here 4 and 12. That should be good, right? 0, 1, 2, 3. That will be 4 multiplied 256. And we can choose a NAT gateway. This is the resource that I told you, and you can see a $sign here. It means that creating a NAT gateway will cost us. So it's up to you. If you want to follow me and create it, be ready that you can have some costs. Of course, we will just create it and delete it quickly, so it shouldn't be expensive. You can also go for pricing to take a look. NAT gateway for me in Singapore. You will see that for an hour will be 0.059 cents, right? Okay, and we can have it also high available, 1 per availability zone. So we chose 2 availability zones. If we chose 3, then it would create 3, but we want only 1 for now. And we can also use VPC endpoints. This is a feature in AWS that allows us to communicate to other services from our private subnets using Amazon Private Link. It's a feature that allows us to communicate with private IPs instead of the public ones. But for now, we will not use it. This S3 gateway would allow us to interact with our files on S3 buckets using private endpoints. And we can enable DNS hostnames and DNS resolution. I will not talk about what is inside each subnet. I will tell you only that Amazon, AWS, they are reserving 5 IPs. One of them is for DNS, but it's not crucial right now to have this knowledge. We are just starting. Create a VPC. Let's create it. And you see that everything is going automatically for us. NAT gateway always take a little bit longer to create. And this is a very nice feature because in actual, in the past you would have to go and create everything manually, right? So we would have to create a VPC, then go to subnets, create subnets, go to root tables, create them also. So meanwhile, when it's creating, you can see that we have a VPC, we have a subnets, we have internet gateway, and it has its own ID, and we have a root table. So I would like to show you, if you go to subnets, Amazon will propagate names here. So you can see that we have public and private subnets, but these are only names. We can freely change it to anything we want. But when we select a subnet and we go to root table, you can see that for our whole VPC, the destination, if we gonna query any of the IPs, private IPs from this seed block, the target will be local. This is by default provided by AWS. So we can communicate in our VPC. And you can see that 0.0.0.0/0, this is white internet. It means that if you cannot find any other root tables, please go to our internet gateway. And this is a root table of public subnet. We have the internet gateway here. We can see that it's attached. We cannot configure anything here. It's all managed by AWS. NAT gateway, it has been created. We see that we have root table, the private one. Let's create it. Let's go there and take a look. And you can see that here the traffic for internet will go via NAT gateway. So the traffic will be from subnet, private subnet 1 or 2 routed via root table to NAT gateway, and then it will go to the internet, but nobody will be able to communicate to our private resources. It's a very nice feature. You could also make it manually, configuring an EC2 instance as a NAT, but as you can see here, it's only like 3, maybe 5 minutes, and it's done, and we don't have to take care of the server. We don't have to patch it or do any other things there. And you can see that the NAT gateway has elastic IP address. This is this static IP attached to this NAT gateway, a public one, and it has also a private one. So this public one, it's elastic IPs. I mean static. It means that it's allocated to this resource, right? If we create an EC2 without elastic IP address, it will be randomly assigned from Amazon pool, but we can create an elastic IP address and then allocate it with EC2 instance or any other resource like NAT gateway. And then we will be sure that every time when we, let's say, stop and start EC2 instance, we will have the same public IP. There's a lot of features here. We will not go through all of them right now. I just want to show you how to create a simple VPC, because in the next lesson, we will create it with Terraform code, and we will be able to create our application load balancer in public subnets. And in another lessons, we will continue our journey to have a simple backend behind the load balancer. So now let's delete the resources that we have. Don't forget, if you have created NAT gateway, to remove it. If you create a delete VPC, you can see that we cannot delete it by default. It's saying that we have a NAT gateway attached, so it's not fully automated. We can delete NAT gateway. Also, we will have to delete the elastic IP, because when it's in use, it's for free. But when you have not allocated to any resource, it will charge you, I think, 50 cents per month, or something like 2.5, I don't remember exactly. So also don't forget to delete. Now we cannot yet. Let's wait for the NAT gateway to be deleted. Yes. Don't forget to make cleanups if you do anything manually. That's very important. We're gonna delete all of our stuff from the VPC. It's already updated, it's deleting. the network interface, it is the network interface of NAT gateway, so it will also be deleted soon, hopefully. And we see NAT gateway has been deleted. Let's refresh here. Not yet. Allocated IP, release. Now we can try to release it. Okay, and it's gone. You could also release it from here. Now let's go back to the VPC and try to delete it again. Okay, and also AWS will detect that nothing is deployed in these subnets, so it will delete all of the things that are in this VPC and they are not needed anymore. Thank you guys. In next lesson we will go with Terraform. Don't forget to subscribe. Don't forget to leave a comment. Don't forget to put the thumb up under the video. Hopefully you enjoy it. Sorry for the 1 week delay, but we are quite busy here in DevOps Codes and we are also hiring right now mid and senior DevOps engineers. So hopefully our team will be growing up and I will have more time to record more videos for you. Have a good day. That was Paweł from DevOps Codes Academy.